The intro to Chapter 10 reviewed two things. First was trigonometric functions, sine, cosine, and tangent. And second was your special right triangles. And that really is a good transition into what we're doing today, which is right triangle trigonometry. The first thing that I want to talk about is cosecant, secant, and cotangent. Remember I mentioned how there's actually 6 trigonometric functions instead of just 3. So you already know sine, cosine, and tangent. Now you're going to know cosecant, secant, and cotangent as well. So that's all 6 of them. Sine, cosine, tangent, we have the phrase so, ka, toa to help us to remember how to write these ratios. Cosecant, secant, and cotangent are just the reciprocals of sine, cosine, and tangent. So we're even going to write that, I'll put it right here. Actually, we'll circle here. They're the reciprocals. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. The most common mistake that I see when writing the 6 trigonometric functions is that students confuse cosecant and secant. So sine goes with cosecant, and cosine goes with secant. And cotangent and tangent kind of sound similar enough that we're fine with that. Let's just try a problem right away. Okay? Ooh, actually, just checking that we know what reciprocal means. If I have a reciprocal and I start with A over B, the reciprocal would be B over A. You just flip the numerator and denominator. Okay, so let's try an example now. The directions say find the values of 6 trigonometric functions for theta. So here's my theta right here. I have the adjacent length, which is 14. I have the opposite length, which is 48. But I am missing the hypotenuse. So before I can even write the 6 trigonometric functions, I need to find out what that hypotenuse length is. In order to do that, since this is a right triangle, you need to ask yourself, how do I find a missing length from a right triangle? And that would be Pythagorean theorem. A squared plus B squared equals C squared. A and B are both the legs. It doesn't matter if you have them flipped or not, but A and B must be legs. C is the hypotenuse. So when I'm writing this equation, it's going to be 14 squared plus 48 squared, because 14 and 48 are both legs of the right triangle, equals, I need to solve for C squared because I'm missing the hypotenuse. And let's just solve for C. 14 squared is 196, plus 48 squared is 2,304. Add those two things together, I get 2,500. Now, in order to solve for C, I need to take the square root of each side. Now, normally, whenever we take the square root of each side, we need to put a plus or minus. However, we're dealing with side lengths, and we cannot have a negative length. So I'm just going to put a positive 50. So 50 is our hypotenuse length. Now we're ready to do sine, cosine, and tangent. We're starting with those 3. So remember, so, ka, toa. Sine is opposite over hypotenuse, so 48 over 50. And if we can, we'd like to simplify that. So they're both divisible by 2, giving me 24 over 25. Cosine is adjacent over hypotenuse. So 14 over 50. Once again, simplify, so they're both divisible by 2. Tangent is opposite over adjacent, so 48 over 14. That gives me 24 over 7, because both were divisible by 2. Now we're ready to write cosecant, secant, and cotangent. I'm just going to use my simplified versions and write the reciprocals of those. So 25 over 24, 25 over 7, and 7 over 24. And that's it. The hardest part is just remembering which one is the reciprocal of which. Otherwise, it's just a pretty easy extra step that we're taking. Part B, once again, we're trying to find all 6 trigonometric functions. This is my reference angle, so I have opposite, adjacent, and I am missing the hypotenuse length. Sometimes I will give you the hypotenuse and you have to solve for one of the legs, so just make sure you're being careful of what we're trying to solve for here. Pythagorean theorem must be leg squared plus leg squared equals hypotenuse squared. So it is 18 squared plus 80 squared equals c squared. Okay? 18 squared is 324. 80 squared is 6,400. And that's set equal to c squared. Add these numbers together, you get 6,724 equals c squared. To get c by itself, I need to take the square root of each side. Once again, normally we would put plus or minus, but because it's a length, we cannot have a negative value, so it's just going to be positive 82. So 82 is my hypotenuse. And now I'm ready to write sine, cosine, and tangent. Sine is opposite over hypotenuse, so 80 over 82. I can simplify by dividing by 2. Cosine is adjacent over hypotenuse, so 18 over 82. Once again, simplify. Tangent is opposite over adjacent. And simplify once again. So now, remember, cosecant theta is the reciprocal of sine of theta. Secant theta is the reciprocal of cosine theta. And cotangent theta is the reciprocal of tangent theta. And I'm just going to flip my simplified versions just to make it easier on myself. And that's it. So now we're going to take a look at another concept we reviewed in the introduction, the special right triangles. So I have those listed out here. You're going to frequently need to determine the values of the trig functions for a 30, 60, 90 or a 45, 45, 90 triangle. So at some point, you will either have this whole thing memorized or you'll be able to find it pretty easily. What I use in order to do these ratios is 1 for the shortest leg on a 30, 60, 90, or a 1 on the leg for a 45, 45, 90. That's because we're going to be dealing with a unit circle here soon, which has a length of 1. So that's going to come into play later. You'll see what I'm talking about. But for now, very, very basic. The best way I can show you how to do this is just by giving you examples. So we're going to use one of these trigonometric functions in order to find a value of x. So we're going to be solving here using these ratios. Part A, I have a 60-degree angle. That's my theta, my reference angle. So if this is my theta, I have opposite being x and the hypotenuse as 100. So which function uses opposite and hypotenuse? If it helps, you can write it out. So, ka, toa. So sine uses opposite and hypotenuse. Technically, so does cosecant, because cosecant would be hypotenuse over opposite. But just so we have less to memorize, let's stick with our basic 3 trig functions you already know. So I have sine of theta equals opposite over hypotenuse. I'm going to plug in what I know here. Sine of theta, my reference angle is 60 degrees. So it's sine of 60 equals opposite, which was x, over hypotenuse, so 100. I'm trying to solve for x. So to get x by itself, I'm going to multiply each side by 100. That gives me x equals 100 sine of 60. Now, sine of 60 is going to be in this table above. Sine of 60 is root 3 over 2. So I'm just going to plug that in, root 3 over 2. And just to show you how I got root 3 over 2, 60 is right here. Sine is opposite over hypotenuse. So opposite is root 3, hypotenuse is 2. So root 3 over 2. And then we want to clean that up. 100 times root 3 all over 2. That becomes 50 root 3. Because 100 divided by 2 is 50. Okay, let's try part B. Now I have a reference angle of 45. It's worth pointing out that your reference angle will always be 30, 60, or 45. You cannot use the 90-degree angle as your theta. Okay, theta is an acute angle of a right triangle, not ever the right angle. So I have the opposite and the hypotenuse here. So sine of 45 equals opposite over hypotenuse. Let's solve for x. You just multiply by 20 on each side. Sine of 45 will be in our table. So here's my special triangle. It's 1, 1, root 2. You could just solve for, okay, sine, this is my 45. Opposite over hypotenuse is 1 over root 2. But then you'd have to rationalize and you'll end up with root 2 over 2. Or you could just look at the table and say, hey, it's root 2 over root 2. But it never hurts to know where I'm getting it from. And then simplify. 20 divided by 2 is 10, so it's 10 root 2. All right, time to check your work. Your theta was 30. We had the opposite and hypotenuse, so you should have said sine of 30 equals x over 74. You multiply each side by 74 and get x equals 74 sine of 30. This was a 30, 60, 90, so I'm going to go up to my table 30, 60, 90. Sine of 30 was 1/2. So you could just plug in 74 times 1/2. Again, I am going to point out, though, how we would have gotten that. So in a 30, 60, 90, the shortest leg is 1, root 3 for the longest, hypotenuse is 2. So for sine of 30, here's my 30, opposite over hypotenuse. I get 1/2. And that would have given me the answer of 37. For the second try problem, I'm just going to write it real quick and go over it. Your theta was 45. You had the opposite and hypotenuse. So sine of 45 equals x over 7 root 2. Multiply 7 root 2 on each side. I get 7 root 2 times sine 45, which is root 2 over 2. and then I simplified it to get